Today's lesson is how to calculate the density of the population given the formula dP, or density of the population, is equal to N over A, where dP equals population density. And N is equal to the number of individuals in the population. Or we could just say the population size. Same thing. And A is equal to the area. Now, when we're doing these calculations, the only real tough part of this, because there's not really much to this formula, is making sure we have appropriate units. The units are just going to be whatever species we have for our number of individuals, say dogs, pigs, chickens, cats, whatever, over here, and then the area is whatever units you're given. Typical unit might be kilometers squared, but we have to remember that there's unit for area in the metric system. The hectare could be per hectare. If it's not metric system, it could be per mile squared. It's always, though, going to be a squared unit. So when we do this calculation, just divide the number divided by the area, go with whatever unit you happen to be given with in the question, and you can't go wrong. The only thing that could be done in a test to make this a little more interesting is if we had to solve for one of the other variables. For example, if you were given the population density and you were given the area, could you find the number of individuals? Well, that just means rearranging the formula. So we start with the formula, density of the population is equal to the number divided by the area. And in this case, if we're trying to solve for the number of individuals here, we would just multiply both sides by area. When you do to one side of the equation, you have to do the other. So area will cancel with area, and we are left with our N, which I'll write over here, is equal to the area times by the density of the population. So you just need to multiply the two together to get the size of the population. So that's if you're given population density and you're given area. Now, there's another possibility. What if you are given the size of the population and you're given the density and you need to find the area? So once again, we start with our original formula. The population density is equal to the number divided by the area. And we're going to rearrange this to solve for area. So the first thing we have to do is we have to get area off the bottom of the fraction here. So I'm going to multiply by area. What I do to one side, I have to do to the other. And that effectively removes our fraction from the equation. So we're now left with A times density of the population is equal to N. And I want area by itself, so now I divide both sides by the density of the population. And that will cancel. So I'm left with area is equal to this population size divided by the density. So given any two of the values, we can find the third. The only other thing you're ever going to encounter on a test is that sometimes the area is not the area at all. Sometimes it's volume. If you're dealing with, say, fish in the ocean or number of sea anemones in an aquarium or something, you might have volume instead. So that just means you substitute volume and your density is the number divided by volume. Most of the questions I've come across, though, they are, in fact, area questions. So speaking of questions we've come across, let's look at a couple of examples. We'll start with one that's about as straightforward as you can get. So here we have in 1957, French scientists transported 2 wild Corsican, how do you say that, mouflon sheep to Hope Island, which has an area of 6 kilometers squared. So we have the area. And it's located midway between Africa and Antarctica. That might be interesting, but it has nothing to do with density. By 1977, the flock had grown to 700 sheep, so we have population size. So in the question it says, what is the density of the Corsican mouflon, I hope I'm saying that right, mouflon sheep population on Hope Island in 1977. So we start with our formula. dP equals number divided by area, or population size divided by area. We have both population size and area. So we have 700 sheep in an area of 6 kilometers squared. So it's just a matter of dividing 700 by 6. 700 divided by 6, just getting my calculator here, comes out to 116.6 repeating. And our unit here is sheet per kilometer squared. Now, how do I write my answer here? Well, in this particular question, it did, where the source where I got this question from, asked for the nearest whole number answer. Nearest whole number answer would, of course, be then 117 sheet per kilometer squared. However, if your teacher is pretty sticky on significant digits, technically we have only one significant digit, because right here, 6 kilometers, that's 6 kilometers squared, I apologize, is only one significant digit. So how do we write this to one significant digit? Well, we would write this as 1 times 10 to the 2, and that's because we have to take our decimal place from here and move it over 2 times, and then with one significant digit, this would just become a 1. So 1 times 10 to the 2 sheet per kilometer squared. However, if we're rounding it just to nearest whole number, 117 sheet per kilometer squared. So that's a pretty straightforward example. Let's look at one that requires a little bit of manipulation of the formula. Let's take a look at this one right here. And I'm going to have to do some erasing here to get some room. All right. So now we're dealing with wolves. There we go. So we've got Jasper National Park. By the way, I happen to live fairly close to Jasper National Park. It's a great place. If you're from somewhere around the world and you're visiting Canada, go to Jasper National Park. Way better than Banff and way cheaper. All right, anyway, we've got animal 1 is a wolf. Animal 2 is an elk. We've got the density of the predator. Well, the predator in a wolf-elk relationship would be the wolf. The wolf eats the elk. And the prey would be the elk in Jasper National Park. In Northwest Territories, it would be the caribou. All right, so what we're asked for in this case is the size of the wolf population in an area of 6,000 kilometers squared in the Northwest Territories. So we're concerned with this set of data. We don't need to worry about the Jasper National Park data. So we start with our formula. Density of the population is equal to the population size divided by the area. And what we're being asked to calculate in this case is the size of the population. So we need to find n. So I'm going to multiply both sides of the equation by a. Remember, when you do to one side of the equation, you have to do to the other. So we're going to cancel a over a, and we are left with n is equal to the area times the density of the population. So we need to know the area, which was given in the original question, as 6,000 kilometers squared. And the density of the population, we want the density of the wolves, which is the density right here of 0.3 per 100 kilometers squared. All right, so we need to know this in kilometers squared rather than 100 kilometers squared. Well, let's just solve this the way it is, and then we'll get the units sorted out in a moment. So I can take 6,000 kilometers squared times 0.3 divided by 100 kilometers squared, and I should have written this. This is wolves per kilometer squared, 0.3 wolves per kilometer squared. So our units are going to cancel because we've got kilometers squared. We're dividing by kilometers squared here. So all I need to do is calculate 6,000 times 0.3 divided by 100, and I get an answer of 18, and this would be 18 wolves. My unit of kilometers squared is canceled now. So correct answer here would be 18. Once again, in this question, it asked for nearest whole number, so nearest whole number is 18. However, again, if we're sticky on significant digits, we have 4 significant digits here, but we have only 1 significant digit here. So if your teacher's technical on this and we want significant digits, that would be equal to, well, we move the decimal place over 1 place, so that would become rounded off to 2 times 10 to the first woes. Again, if significant digits are a concern on this particular question, it did ask for rounding to the nearest known number. So I hope that helps in figuring out population density, probably the easiest of all the population formulas and calculations we can do.